All right, so what are we doing? You gonna verbalize stuff? Okay. Go ahead. Okay. Oops, hold on a second. I'm sorry. Forgot to turn my writing tool on. Okay. 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 So even if I don't recognize what this is incidentally, the second equation is a straight line. It's in the form y equal mx plus b. And the first equation is a circle. So I'm going to have something, and in fact it's a circle with its center at the origin, and the straight line is going to look something like that. So I know I'm going to have two solutions right there and right there, wherever these two intersect. Okay? So that's one of the reasons for being able to translate these to graphical images, is that it immediately tells you you're going to have two solutions to this. Okay, and they told you to use substitution. So what's my first step? So read the next line to me. No. It's plus. Not y. Okay. In other words, is all I did was take whatever y is equal to, put it in parentheses. The parentheses are needed, and do that process. Now we got to solve this quadratic. What's the first step to solving that quadratic? So we still have our first x squared. What does this whole thing become when I FOIL it? I'm going to write it. Okay, go ahead. Keep going. Okay, stop for a moment. Notice those two terms always combine. So if I want to skip a step, I'm going to combine those 20x's and make it minus 40x. Now, what's the last term? It's minus 10 times, yes, it's minus 10 times minus 10. That's plus 100. If you get that sign wrong, you're getting the problem wrong. No two ways about it. Okay? So getting the sign correct is every bit as important as any other step in this problem. You get that sign wrong, you're getting the problem wrong. Okay, now simplify. Remove those brackets. Where are you getting that? Well, what's 1 plus 4? Great. Okay. Now notice that I've got a quadratic that's going to be difficult to factor. But how can I make it easier? Can I get rid of this 5? In other words, can I turn this into an elementary quadratic? Okay, what's the next line? Good. So there's my new equation. Much easier to solve than this one. In fact, I can factor that rather easily. Factor that. Second step. Beautiful. Third step. Verbalize the third step. Okay. When I said verbalize the third step, what I meant was you want factors of 15 that add to 8. And that's 5 and 3. And it doesn't matter which way they go. So what are my solutions? Okay, that's one of them. It's not, yeah, it wasn't -5. I didn't hear your negative. It's just 5. In other words, the way you solve these is you set each one of them equal to 0. If I say x minus 5 equals 0, then x equals 5. If I say x minus 3 equals 0, then x equals 3. So your two solutions are 5 and 3. Okay? That's the 5 right there. Don't know what the y coordinate is yet. That's the 3 right there. I can just tell graphically that that's the way it has to be. Okay? Now, they said solve this, right? So you have to solve for both x and y. Well, I got two different values for x, which I expected because I knew I had a circle intersecting with a straight line. That's going to give you two values for x. That's what I got. Now give me the two values for y that go with that x. Up here, what's the y value? Go to your equation that has y equals. What do you get? This one right here. Okay, that's the y value when x is equal to 5. What's the y value when x is equal to 3? So you can see my picture is not quite accurate, but close enough. The main purpose of my drawing is to tell me that I'm going to have two solutions. And I'm going to have an x and y value at each solution. In reality, if I draw it to scale, I've got that circle with radius 5. But let's see, 5, 0, so the line is going to cross there, and then it's going to cross about there. So the line will look like that, okay? And that gives you the correct 2 points that we've labeled. Okay? What else you got? Again, that's going to be a circle. Go ahead. Ooh. Okay. It's going to be a circle that its origin is not, or the center is not the origin. Okay. Okay. notice that I line everything up. Okay. Now, do they give you any instructions on what method to use here? Do they tell you to use, okay, so they let you do it however you want. What are we going to do? Yeah, perfect. What's this figure right here? Is that a circle, a straight line, a parabola? What is it? It is a circle. It's a circle that's origin is not at the center because of this 16x term right there. Okay? In other words, if I didn't have that 16x term, I would know that the origin of the circle is the center of the circle. What's this figure right here? It's actually a hyperbola. Remember what a hyperbola looks like? Kind of like that. Okay, that's a hyperbola. When you get to conic sections, and the fact that they're giving you so many conic sections leads me to believe that you've gotten to conic sections already. Yes or no? Are you familiar with that word, conic sections? They're parabolas, circles, ellipses, and hyperbolas. Okay, so they haven't gotten to that yet. So they don't really care whether you recognize those two things or not as a circle and a hyperbola. Nonetheless, we can solve it. What's the best way to solve it? Should I add the two equations? Subtract the two equations? What should I do? Yeah, notice the y squared is going to go away if I add those. So tell me what I get. Notice there's a minus sign in there. I wrote it a little bit too far in front. Okay, plus 30. And now, notice, this is a quadratic. It's going to produce two solutions for x, which means we're going to have a solution for x and y, two of those. It's the best way to solve this quadratic. What's the best way to solve this quadratic? First step. Okay, okay, so that reduces it to what? Huh, that's the same quadratic we just had. Interesting. What does that factor into? Which means your solution is x equal 5 and x equal 3, but they want the solution for x and y. So how do we figure out what's y? There's going to be a y value when x equals 5, and there's going to be a y value when x equals 3. Which equation is the easiest one to solve for y? Yeah, probably. So the second one, if I'm going to solve for y, let's put all the x's on one side. And let's put the y squared on the other side. So y is going to be the plus or minus square root of x squared minus 9. See what I'm doing? Okay, give me the first y when x equals 5. Okay, what's square root of 16? Okay, it's plus or minus. So this y, when x equals 5, it's plus or minus 4. Now, what about when x equals 3? Okay, so here's my solutions. Now, this might look like strange, but if I know what shapes I'm looking at, it's going to make perfect sense. Okay, this top equation is a circle. And it's a circle that has its origin right about 2. No, let's see. Be about 4. Okay? And it's going to have a radius of square root of 39, which is about 6. So it's going to look something like that. Okay? That's the first equation. Now, the second equation is a hyperbola. And a hyperbola looks kind of like this. So notice I have 4 solutions. I should. There's 4 points of intersection, right? Well, one of them is when x is equal to 4. Well, I get a y value of plus 4. So when x is equal to 5, I get a y value of 4, but I also have this point down here where when x is equal to 5, y is equal to minus 4. That fits my picture, right? Okay, the second set, when x is equal to 3, y is equal to 0. Well, I haven't drawn that quite right. When x is equal to 3, y is equal to 0. No, there's x equal to 3. Y is equal to 0. I haven't drawn my circle correctly. This is what we're looking at. Only this point right here is x equals 3, y equals 0. Only one point. Notice that when one half of the hyperbola is tangent to the circle, you only get one solution. And that's that one right there. When the hyperbola crosses the circle in 2 spots, you get 2 solutions. Well, we didn't have to know that we were looking at a circle and a hyperbola. We really didn't. Because all we did was do algebra. And the algebra pointed us to those 2 solutions. After looking at them graphically, we can see why they make sense. But don't really need to do that. It's just helpful. Okay. All right, what else you got? Okay. H of x, or h of t, excuse me. That's what it should say, h of t, right? Meaning the height of the object, based on a time, is minus 16t squared plus 240. Do they give you that equation? What's that? Yeah. Yeah, h of t, that's a standard equation for anything that is affected by gravity. In other words, that minus 16t squared comes from the force of gravity. Gravity accelerates an object by 32 foot per second per second. And then the plus 240 is the height that it starts at. And if they dropped it with some velocity, let's say somebody was standing on that roof and threw the book down instead of just dropping it, then you'd have a t term in there. But there's no t term, and the coefficient of the t term is the velocity with which it is released. And from the way you read the problem, it looks like it was just dropped. Okay? So it was not dropped with any velocity. It was dropped with zero velocity, which means there's no t term. It's a quadratic that's just these two terms. Now, what question are they asking? When does it hit the ground? Well, what's h of t when it hits the ground? What's h of t stand for? Okay, the height based on time. So what is the height when it hits the ground? So I'm going to put a big fat 0 for h of t. And then I'm going to solve the equation. Well, that's relatively easy to solve. I move the 240 over there. I divide both sides by 16. 16 goes into 240 15 times. So t, is that right? Do you have a calculator? Here I got one. 240 divided by 16. Yep, that's 15. So t squared equals 15. So t equals what? Yeah, but it's plus or minus. Always. Whenever you're solving an equation, by taking the square root of both sides, remember to start your answer with the words plus or minus. Now, having said that, we're dealing with a problem that is about time, and time can never be negative. So, in this case, I don't care, it's plus no matter what. That's how long it's going to take to hit the ground. The square root of 15, which is about 3.8 seconds, something like that. Whatever the square root of 15 is. Okay? The key thing with this thing is knowing what that is. And trust me, it's always going to be height. This is not the first projectile motion problem you're going to run into. Okay, this is not just projectile motion. It's also the motion based strictly on gravity. When you drop something from a height, it falls to the ground based on this formula right there, plus whatever its height was. The key thing on this is to know that that is height. And so when they say, what's the height when it hits the ground? Well, when you're on the ground, the height is 0. Right? If they'd have said, how long does it take to hit a height of 120 feet? Well, then I would have substituted 120 into that equation and tried to solve it. Okay. What else? We got time for one more. Okay? Really? Okay. First step. Yes. In other words, the first thing you should notice is this is not a normal quadratic. It does not have an x term. It's got an x squared term, and it's got numbers, but there's no x term. Those are always easier. That means you're not going to have to factor. What you're going to do is try to solve for x squared, and then you're going to take the square root of both sides to come up with your answer. So to solve for x squared, I got to first get rid of that 10. Okay, so let's add 10 to both sides. Okay, you with me? Now what? I now have minus 6x squared equals minus 54. Not yet. You haven't gotten rid of that minus 6 yet. You wait until you get to x squared before you take the square root of both sides. Always. By what? Okay, so what's x squared equal to? In other words, I'm going to do what you said. I'm going to, yeah, okay. Plus or, no, you're right, 9. So what's x equal to? Plus or minus 3. Again, whenever you are taking the square root of both sides of an equation to solve it, always, always, always begin your answer with the words plus or minus. It'll cost you half credit if you don't put that in there. It definitely will. You would hate to lose half credit on this easy problem that you know how to do. And you will lose half credit if you do not include that. Now, this problem is not based on time, so I cannot ignore a negative sign. If this was a projectile motion or a falling object problem and t was the variable, well, I know time can never be negative, so I don't have to put the plus or minus in there. But this is just a mathematical quadratic where you have a variable x. You definitely need the plus or minus with this problem. Okay. You good, or you want to do another one? Okay. Brandon, you have a good evening. I'll talk to you next time.